Dear students, today we are going to talk about preparation of chlorine. Chlorine, its preparation only. I am going to concentrate only on preparation. Of course, you have got a rough idea about chlorine. It is a gas, greenish yellow colored gas, irritating odor, leads to headache. If you inhale larger quantities, even fatal is possible. That's about introduction of chlorine. And apart from that, you should know chlorine is a best oxidizing agent. It is because of this oxidizing behavior, it can bleach, it can be used as a bleaching agent also. Alright. Now let us go into the preparation. It can be prepared from its salt because chlorine is mostly available in the form of its salt, mainly sodium chloride in seawater. How to prepare chlorine from sodium chloride? So preparation. First method. When chloride salt is oxidized using manganese dioxide in presence of an acid, because the salt has to be broken using an acid. Suppose if we take only hydrogen chloride or hydrochloric acid, no need to go in for sulfuric acid. If you use salt, sulfuric acid is mandatory. What will happen? The manganese will become manganese chloride. Sodium will become sodium bisulfite. With that, water and chlorine will be formed. So what are the possibilities? Mn will become MnCl2. Sodium will become sodium bisulfate. Water and chlorine. These are all the products we are getting. Very lengthier product. Very lengthier. Na sodium becomes sodium bisulfate, manganese chloride, water and chlorine. This is the usual process. Whenever HCl is made to react with, say, an oxidizing agent, MnCl2, you may get MnO2, you may get manganese chloride, water and chlorine. Manganese chloride, water and chlorine you will be getting if HCl is used. Now we are using sodium chloride, a salt. To break the salt, we are using acid. Therefore, in addition to the products, expected product, what are the expected products here? MnCl2, water and Cl2. These are the expected products. Manganese dioxide is an oxidizing agent. It oxidizes HCl into chlorine. Thereby, hydrogen combines with oxygen to become water, chlorine combines with manganese to become manganese chloride. If we use sodium chloride, it will give sodium bisulfate, also extra. That's what we have added here. And how to balance the equation? Simple to balance. MnCl2, Cl2. At least 4 chlorine atoms we have in the product side. MnCl2 and Cl2. Therefore 4. And all the 2 oxygen atoms should go as water. Therefore, naturally, we need 2 H2SO4. 2 may not be sufficient. All right, let it be. Now 4 sodium atoms. Therefore, 4 NaHSO4. Since 4 sulfate radicals, 4 H2SO4. Out of 8 hydrogen atoms here, 4 are in the form of sodium bisulfite. Remaining 4 should be here, therefore 2. 4 plus 4, 8 hydrogen. 2 oxygen, balance equation. Very simple to balance. We have started with 4 chlorine, therefore 4. It should be either 2 or 4. Cl2 we are getting, therefore 2. Another 2 with MnCl2. 4 sodium, therefore 4. 4 sulfate, therefore 4. Out of 8 hydrogen, 4 are here, 4 should be here. Oxygen is also balanced. That's all. We have prepared a chlorine from sodium chloride. Then second method, from hydrogen chloride, hydrochloric acid. From HCl by using different oxidizing agents. What are the different oxidizing agents we may use? We may use manganese dioxide, lead dioxide, BbO2, MnO2, potassium permanganate, potassium dichromate. You should know the molecular formula thoroughly. Lead dioxide, BbO2, manganese dioxide, potassium permanganate, KMnO4, potassium dichromate, K2Cl. Very frequently used oxidizing agents. Therefore, you should know the molecular formula. It's not so difficult also. Often you will be using this. When these oxidizing agents are made to react with HCl, that's all, simply HCl. HCl. What are the expected products? We can guess and write. Lead will become lead chloride. Hydrogen will become water. Apart from that, chlorine. Manganese chloride. Water, chlorine. Apart from that, NaHSO4. Here, BbCl2, water, Cl2. MnCl2, water, Cl2. KCl, MnCl2, water, Cl2. KCl, CrCl3, chromium usual oxidation state 3, therefore chromium chloride, water, Cl. So, you try to complete the equation. BbCl2, whether you started to write BbCl2, H2O, Cl2. MnCl2, H2O, Cl2. KCl, MnCl2, H2O, Cl2. KCl, CrCl3, H2O, Cl2. That's all. You might have written yourself. Now we can balance. How to balance? 2 oxygen, therefore 2. 4 hydrogen, therefore 4. Balanced equation. BbCl2 plus 2H2O plus Cl2. Same thing. 2, 4, 4. 2Cl here. 2. Balanced equation. Here, since we have got a little bit one more compound extra, the balancing may be a little bit difficult, but not so difficult. Chlorine should be in even number, therefore 2. 2KMnO4. 2MnCl2. 8 oxygen, 8 H2O. Now count the chlorine, rest you have to fill that, that's all. 2 KCl, 2 MnCl2, 8 H2O you have done. 16 hydrogen, therefore 16 HCl. Out of 16 chlorine, 2 are here, 4 are here. 2 plus 4. 2 plus 4. 2 plus 4. 6. If you subtract 6, 10, I should write. Therefore 5. 5 Cl2 means 10 chlorine. Balanced equation. Now in the next case, 2K, therefore 2. 2 chromium, therefore 2. Alright. 7 oxygen, 7 H2O. Now let us try to complete. 14 hydrogen, therefore 14 HCl. 2 KCl, 2 chlorine. 2 CrCl3, 6 chlorine. Totally 8. Out of 14, 18 are with salt. Out of 14, 8 are with potassium and chromium chloride. Remaining how many? 6. Therefore 3Cl. That's all. We have prepared chlorine by using oxidizing agents. So oxidation of HCl using oxidation of HCl. Using different oxidizing agents. What are the different oxidizing agents? Lead dioxide, BbO. Using the oxidizing agents. What are the oxidizing agents we have used? BbO2, MnO2, KMnO4, potassium permanganate, and then potassium dichromate. These are the oxidizing agents we have used. What are the products we have got? Lead chloride, water chlorine. MnCl2, water chlorine. KCl, MnCl2, water chlorine. KCl, CrCl3, chromium chloride, water and chlorine. These are the products we have got. You know how to balance the equation. Just check. You can try yourself and you can try to balance yourself. It is so interesting. Preparation of chlorine is so interesting. It can also be prepared from bleaching powder. In the municipal water or corporation water or even from village panchayat or town panchayat, if we get water, they will be always using bleaching powder to make it clean. So sometimes you will be getting chlorine smell if the bleaching powder happens to be in excess. So in bleaching powder, CaCl, OCl I can say, in short, it is actual structure goes like this. Therefore, I have written CaCl, OCl, but we used to write CaOCl2, molecular formula CaOCl2. That is bleaching powder. So third one from bleaching powder. When bleaching powder is even hydrolyzed with water, you will be getting chlorine. But apt method is allowed to react with acetyl or sulfuric acid. Dilute acids. When bleaching powder is made to react with dilute mineral acids like hydrochloric acid or sulfuric acid, you will be getting calcium chloride, water and chlorine. In the next case, you will be getting calcium sulfate, water and chlorine. That's all. How to balance the equation? CaCl to calcium chloride balancing 2, 1, water, chlorine. CaCl to 1 oxygen, 2 hydrogen, H2O. CaCl to H2O plus Cl2. That's all. Balance the equation. CaCl to H2O plus Cl2. If it is sulfuric acid, you will be getting calcium sulfate, water and then chlorine. CaCl2, water and chlorine. That means the metal calcium get combined with the chloride radical and sulfate radical in acids to become salt, water and chlorine. Chlorine from bleaching powder is being liberated. This is how we prepare chlorine. It is the preparation from lab, we can say, laboratory method of preparation or simple methods of preparation. If we go in for manufacture of chlorine, we have to go in for a little bit complication. We have 2 methods. Electrolysis of brine water. Brine means sea water. Brine water. Not brain. It's not brine. Brine water. Sea water. Nothing but sea water. Brine solution we say. From that we can prepare chlorine. That is one method. Electrolysis of brine solution. Electrolysis. So one method, because sea water contains plenty of chlorine, therefore we can extract from that. Second method, decons process. Decons process. These are the 2 methods of preparation of chlorine. Those 2 methods we are going to see now. Let me rub this. Just to go through, look at it, and we shall go into these 2 methods. You have to practice. Unless otherwise you prepare, again and again you cannot be an expert. We started to write our first alphabet, Tamil alphabet A several times, English alphabet A several times. Now we are so much familiar. How many times you have written A? Do you remember? 100 times? 1,000? 10,000? Lakh? More than that? Just think how many times you might have written the letter A in your lifespan of about 16 to 17 years. You might have written letter A several times. Likewise, unless otherwise you repeat writing, practicing, you cannot expertise in this. Now let us go into manufacture of preparation. I have written that includes manufacture also. All right. First method, electrolysis of brine solution. Electrolysis of brine solution. What happens when it is electrolyzed? Let me write in 3 compartments. Sodium chloride ionizes to form sodium ion and chloride ion. Because in brine solution we have sodium chloride and water. That's what present in brine solution. Water is also getting ionized to become H plus and OH minus. Of course, it is reversible. It's not reversible, it is reversible. That's the ionization process in the first step. During electrolysis of brine solution, when we start to electrolyze brine solution, it gets ionized. And at cathode, what are the ions available at cathode? Cations. Cathode means negative electrode, positively charged ion is known as cation. It is cation, it is anion. Cathode means negative electrode. Cation means positively charged ion. So Na plus ions accept before that. This Na plus and OH minus get combined to become NaOH, sodium hydroxide solution. So from brine solution, these 2 get ionized and the sodium ion and hydroxide ion get combined to become sodium hydroxide. Of course, that exists in the form of sodium ion and hydroxide. That's different. It's not, I am saying literally it get combined to become sodium ion, sodium hydroxide. It is existing in the form of Na plus and OH minus only. Alright? And we are saying it as a molecule, that's all. Truly speaking, it is Na plus and OH minus again. Hydrogen ions travel to cathode, there it gains electron to become hydrogen atom. When two such hydrogen atoms get combined, it becomes hydrogen molecule. So hydrogen molecule is liberated at cathode. Likewise, chloride ion, being negatively charged ion, it moves towards anode. Anode means positive electrode. Anion means negatively charged ion. The negatively charged ion, Cl minus ion, liberates chlorine. Cl atom with the liberation of chlorine. Two such chlorine atoms when get combined will be getting chlorine. So chlorine will be liberated at anode and hydrogen will be liberated at cathode. Thereby we will be separating hydrogen and chlorine. So that is the chemistry involved in the electrolysis of brine solution. We have not entered into the actual setup which involves only engineering. So this is the scientific matter involved. When sodium chloride solution is electrolyzed, ionized, sodium hydroxide is formed. Hydrogen ion travels to cathode to become hydrogen molecule, and at anode, chloride ion travels to become chlorine molecule. Chlorine is liberated anode, hydrogen is liberated cathode. That's a very simple electrolysis method. The next method, Deacon's method. Second method of preparation, Deacon's method of preparation of or manufacture of chlorine. How to manufacture chlorine? By Deacon's method. Deacon's method of manufacture. We are going to oxidize hydrochloric acid, air, in the presence of cuprous chloride, Cu2Cl2 at about 400 degrees Celsius. That means 673 Kelvin. So in the actual setup, we pass mixture of hydrogen chloride and oxygen from the bottom to top. There will be lot of hurdles like this. And pumice stone. We used to say pumice stone. Lot of such stones are placed here just to make hurdle. All right. So when it passes to the top and it is surrounded by a temperature of about 723 at 723 Kelvin, hot air jacket will be pressed outside and hot gases will be moving at the top around it, so that the temperature will be maintained about 673. At 723 Kelvin, using air jacket, we are passing hot gas, so that hydrogen chloride is oxidized by air into chlorine. Hydrogen get combined with oxygen to become water, and we will be getting chlorine. So this is how we prepare. Just imagine hydrogen chloride, air is sent from bottom to top. Cupric chloride is kept as a catalyst. Cuprous chloride, it is cuprous chloride. Cupric means CuCl2. It is cupric, where the valency of copper is 2. Cuprous means CuCl, but it exists as dimer, therefore Cu2Cl2. It is cupric, it is cuprous. It can exist as dimer, therefore Cu2Cl2. Alright? So in the presence of cuprous chloride catalyst, hydrogen chloride is oxidized. In what way the reaction will be? Water and chlorine, that's all. Water and chlorine. This is how the reaction goes. Alright? When hydrogen chloride is oxidized using air in presence of cuprous chloride at 400 degrees Celsius, we get chlorine. What is the actual course of reaction? The cuprous chloride, 2 molecules of cuprous chloride takes up a molecule of oxygen. 2 molecules of cuprous chloride takes up a molecule of oxygen. Therefore, I written 2 here. Cu2OCl2. Cu2, only one oxygen. But O we have written as O2, therefore 2 molecules. It becomes cuprous oxychloride. Cuprous oxychloride. Alright. For one molecule, one oxygen. But we have to write O2, therefore 2 molecules. Cuprous oxychloride. This cuprous oxychloride, Cu2OCl2, then reacts with HCl to become cupric chloride. CuCl2. 2 copper, therefore 2. It should be even number, therefore 2. 2 copper, 4 chlorine. Plus water, that's all. It becomes cupric chloride. Cuprous chloride becomes cupric chloride. The cupric chloride then get decomposed to become cuprous chloride. CuCl and Cl. But CuC, it has to exist as dimer. It has to be represented Cl2, therefore 2. 2 molecules of cupric chloride gives 2 Cu2Cl2 and Cl2. Cuprous chloride is regenerated. This is the catalytic reaction. The catalyst is getting involved. It combines with oxygen to become cuprous oxychloride and then reacts with HCl to become cupric chloride. Cupric chloride then decomposes to form chlorine. This is how the reaction goes. If we sum up, you will be getting this equation. How to sum up and how to balance this equation? Let us try. Just a 2? No. We have 2 oxygen. Therefore, if we are getting 2 H2O, therefore 4 hydrogen. 4 chlorine, therefore 2 Cl. That's all. This is how the reaction goes. Hydrochloric acid combines with oxygen to become water and chlorine. This is Deacon's method of preparation. Just an explanation. We pass air and HCl in a tower made of a lot of hurdles. Female stones are present. And in the outer jacket, we are passing hot air at the temperature of 723 Kelvin, here 673. At this temperature, the reaction takes place. The catalytic reaction is shown here. These 3 steps together I have written here. That's all. That is about manufacture of chlorine. So with that, we end up with preparation and manufacture of chlorine. In the next class, let us go into chemical properties with a little bit physical properties of chlorine. We can say almost physical properties we have touched even then. When I start to explain about properties of chlorine, we will be going into physical as well as chemical properties. Thank you.